Hello, everyone. My name is Casey Rofsky, and I am a technical Scrum Master at Vanguard. I'm joined today by Sophia Trump and Katie Schwang, who are cloud engineers on our API platform team. So thank you so much for joining us for API Gateways. Do I need one, none, or many? Balancing multiple API gateways at Vanguard. Over the past several years, Vanguard has been on an API modernization journey. In that time, we've had to ask ourselves these same questions. We've considered the pros and cons around API gateways to decide what made the most sense for our API lifecycle. Hopefully, by the end of this session, we'll provide you with some insights that can help you decide what's best for your team. But before we do that, Sophia is going to tell you a little bit about Vanguard.
Casey. So who is Vanguard? First, we'll start off by providing some context about Vanguard to set the stage for the rest of the presentation. At a high level, Vanguard is an investment company with headquarters just outside of Philadelphia, Pennsylvania. And our main business structure that sets us apart is that we're owned by the people who own our funds. To put this into numbers, our IT division is fairly large, with over 8,000 people from across 5 different countries in IT alone. And we've grown to have over $8 trillion of assets under management. A key part of our growth from the tech perspective is APIs because they give us the technical and business agility to serve our clients, mainly by allowing us to shift from a monolithic software architecture to an APIs and microservices architecture in the cloud. So naturally, as the number of APIs at Vanguard has grown, so has the need for API gateways. So next, let's set the context for why API gateways were introduced into our tech stack in the first place.
First of all, let's talk about what an API gateway is. An API gateway serves the purpose of a proxy server between API consumers and producers. It's an important piece of infrastructure that facilitates API communication at a centralized point. By acting as a single point of entry for a client request, API gateways can ensure clients don't have to be involved with the complexity of some backend services. At its core, API gateways are used to accept client requests and push them along to the appropriate service after some processing. At Vanguard, we understand how an API gateway gives us control and flexibility, while letting us pursue an architecture based on loosely coupled microservices rather than complex monolithic systems. Having an API management platform provides our API producers with the ability to focus on serving the consumers on the platform while we handle common functionality implemented at the gateway level. API gateways provide many capabilities, but we really want to highlight the security, routing, and monitoring and analytics that come along with owning your own. You might be asking yourself if you even really need an API gateway, which is an important first thing to assess. Generally, if you're foreseeing you would need configurations for multiple API services to have security, optimization, or monitoring and logging activity, adding an API gateway to your architecture can be a great addition. Creating a reliable API system will help meet client demands, especially as you begin to scale your operations. On the flip side, without an API gateway, each API would have to be individually configured with security and optimization. As you break up monoliths into multiple microservices, these configurations can be more prone to mistakes, and monitoring analytics would be difficult to manage and keep track of. Imagine this: you have 2 or 3 APIs that consumers can call. You need to make sure that they all have their configuration set up individually. Now consider you have a lot more. Where is the tipping point for you to switch to an API gateway? The value of having a gateway goes up in line with economies of scale. The more APIs you have, the harder they'll get to manage without a standardized platform. Here, you can see API gateways provide abstractions over common functions, and how having hundreds of APIs, even thousands, can make it impossible to account for, especially on a larger scale when you'll need to make future configuration changes. Let's dive into the various benefits of having one API gateway over having none. The API gateway can be responsible for securing APIs as another barrier between your clients and your services. Because of this extra layer, API endpoints are not exposed publicly. However, a gateway doesn't need to solve all security issues on its own, since it's not just the act of proxying that adds security, but also the responsibilities we set while we proxy. Consider the use of other tools to complement your API strategy. For example, authorization and authentication through the use of tokens can be produced by a separate identity provider to be validated by the gateway. Or a circuit breaker can sit in your gateway as a state machine to ensure there's not too much traffic going to a failing backend. Additional infrastructure can be stood up in conjunction with an API gateway, like a content delivery network or web application firewall. Custom plugins can be added to your gateway at the global or service level. The takeaway from this is your API gateway doesn't need to solve all your security issues on its own, but services also don't need to implement extra infrastructure individually. In its purest form, API gateways can be used to provide free implementation related to routing logic and rules. But more and more requests flowing through the gateway can be hard to manage and poses a security risk. Like I mentioned before, a circuit breaker can be a tool in the gateway that manages traffic volumes. You might want a cache to reduce latency in traffic, store session data for reuse, or even scope access. Fault tolerance can enable an API to continue its intended operation even in the event of a failure. Traffic management at the gateway can protect APIs against traffic spikes and denial of service attacks through throttling, and limit the number of connections apps can make over a period of time through quotas. Similarly, rate limiting can prevent too many connections being made to your API concurrently, and traffic shaping further regulates flow to optimize network performance. Adding a gateway to your API strategy gives you more clarity into the health of your APIs and the traffic that goes through them. Just being on the gateway gives APIs monitoring capabilities, but there is also transparency having multiple APIs on the same platform. You can get insight into all API services to better inform decisions. Monitoring systems are easily integrated with API gateways to provide real-time or historic metrics and give you a better understanding of the state of your API gateway system as a whole. Alerting, on the other hand, makes sure that you stay up to date with the status of your APIs. Analytics can help to capture all traffic information and give you the better means to inspect that traffic to make decisions. With a gateway, you can have one place to see the number of API calls that resulted in a 400 or 500 status code and a comprehensive error rate, or see the amount of time APIs respond to requests through performance and latency. An analytics dashboard gives you the ability to see usage composition of an API or which APIs are getting more or less traffic. We can only function as a business when we can see the big picture, and an API gateway gives us that overview of the entire gateway system. That way, we're best able to adjust where needed and find not only the errors as they happen, but see how to quickly get them resolved. Next, let's talk about Vanguard's API strategy and how we're using these benefits to the fullest. At Vanguard, our first use case was creating an API gateway specifically for APIs receiving external traffic, like when a client calls a Vanguard API from outside our virtual private cloud. Since we want to offload a lot of responsibilities from our services, Vanguard gives our Kong external API gateway, or KEG like we like to call it, control over a lot of security measures, traffic management, and analytics. As it pertains to authentication, the KEG receives requests with opaque tokens and exchanges them for JSON Web Tokens at the identity provider service. This is done to decrease the amount of information exposed in the event of a leaked token, as JOTs encode custom payloads instead of encrypt. Although this does filter unauthorized external requests, there's currently no way for the upstream service to securely verify that the request is coming from the KEG. Additionally, the KEG is completely unaware of the JOT payload and does not do anything besides check the signature. Hence, there's no way to encode rules for scopes, and for this reason, your service must implement checking the JOT signature and validating scope rules. For security, in most cases, if called through the gateway URLs, the request will go through a CDN or content delivery network, which adds some security. All requests are guaranteed to go through a Vanguard WAF or Web Application Firewall, which enforces some of the security rules. The CAC provides the ability to limit the number of requests per specific time frame. Currently, this can only be done per service and not per individual consumer. Currently, we only provide access to raw logs, and these logs contain information about the received and proxied requests from the perspective of the KEG. They can help you to reason about uptime and performance of your service. However, it will not help you with collecting application-specific logs like runtime errors. Your service needs to implement the collection of those. I'll pass it off to Casey to talk about having more than one gateway.
Thank you. So now that we know all the benefits about having a single API gateway, let's take a look at why you would want multiple. So as Katie covered, gateways can solve for many use cases around security, routing, and analytics. In our case study, you saw how a single external API gateway satisfied Vanguard's need to safely provide APIs to external consumers. However, there are some situations where a single API gateway cannot satisfy a team's needs. As Vanguard matured in the API space, we uncovered several mutually exclusive requirements that couldn't be satisfied by a single API gateway. These requirements were around stable URLs, developer portals, global plugins, and API standardization. So let's start with stable URLs. Earlier, Katie mentioned that API gateways are used to route traffic to a specific API via a stable URL. Stable URLs, which are also referred to as persistent URLs, provide an alternate way to call an API other than by a direct route. Where a direct route may contain references to an API's underlying architecture, a stable URL will not. The benefit here is that if there are any changes to the API's architecture, there will be no consumer impacts. The URL remains agnostic to any of those changes. So let's take a look back at our Vanguard case study. We created an external API gateway that provided a stable URL for each of our externally facing APIs. And this was great for our external consumers. However, these consumers only account for a small portion of Vanguard's API users. A majority of Vanguard's APIs are actually used by our own developers in-house. And since those APIs only have internal users, they aren't candidates for the external API gateway. This meant that our developers could not utilize the external gateway's stable URLs. One way to bring that functionality to our internal developers could be to stand up a separate internal API gateway specifically for these in-house APIs. The next requirement that we came upon was having a developer portal. So the Vanguard external API gateway does not currently have a developer portal, and this is because our external APIs are only exposed to specific vendors. Instead of having one general portal open to all consumers, API information is provided directly to the specific consumer of that API. While we don't have a use case for our external consumers right now, our internal consumers would benefit greatly from having a developer portal. For example, one of our IT subdivisions has over 100 APIs. It's difficult for our developers to be aware of all the APIs available to them without having a portal of some kind. If that subdivision opted to create an internal Kong API gateway, they could then also spin up a Kong developer portal. And from there, teams would have the ability to search through all of the APIs that we offer internally. The third requirement that we found was the need for separate global plugins. One unique aspect of Kong API gateways is that they provide teams with the ability to enable custom plugins. The use of these custom plugins is further customizable in that API teams can opt in or out of using certain plugins. However, some plugins are implemented at a universal level. This means that any API deployed to the gateway has to utilize that plugin. So if a given API gateway had a global logging plugin that appended a request to a file, that would be required. But what if a team had a use case where they did not want their request to be logged? They wouldn't be able to onboard onto that API gateway because of that universal requirement. If enough APIs ran into that same conflict, a potential solution could be to have separate API gateways for each use case. That way, teams could still take advantage of having universally mandated plugins without sacrificing their API's unique needs. The last requirement was around standards imposed onto external Vanguard APIs. For an API to be published to our external API gateway, it needs to comply with rigorous standards. To enforce this, our team created a linter. A linter is a program that is used to analyze a set of source code. This is typically done to check for bugs or security violations. The same is true for our linter, except that ours also checked that a given API met our best practices and standards. If an API does not pass the linter, it's blocked from deploying to our external API gateway until it's up to code. Though, as I've mentioned, most of Vanguard's APIs are internal only. As such, they will not be exposed outside of the Vanguard firewall. Since these APIs are only being consumed internally, they don't need to abide by such strict mandates. Obviously, we want our APIs to conform to best practices, but enforcing such rigorous standards on internal APIs could slow down an API team's development, especially if they're only deploying to non-prod. This issue could be solved if internal APIs deployed to their own gateway that does not have the same linting requirements. So on their own, each of these reasons is not necessarily cause for standing up a new API gateway. A new gateway could solve each of these needs, but it isn't the only solution. For example, instead of setting up an entirely new gateway to get stable URLs, a team could simply create a regionless URL for their API. It's because we identified multiple requirements that could each be solved by standing up another API gateway that we decided to do so. While we believe this was the best solution, it's important to note that maintaining a gateway can add potential risks and complications to your workflow. To speak a little bit more on that, I'm going to pass it over to Sophia.
Thanks, Casey. So now that Katie and Casey have talked about the benefits of API gateways and why Vanguard decided to implement multiple API gateways, let's talk about how you in the audience would go about deciding what is the best application for you. Do I choose one, none, or many API gateways? So let's dig into that. Let's start by thinking about the considerations and the risks. What are the potential drawbacks of introducing an API gateway into my architecture? The general rule of thumb that we tend to take in decisions like these at Vanguard tends to be, how can we provide the least dose of infrastructure while still providing the greatest benefit? And this is because we almost always want to favor the most elegant and simplistic design to minimize risk and complexity. API gateways also have their limitations, and ultimately for us, we decided the reward of API gateways outweighed the risks. However, there were three things that we wanted to take into consideration when we were weighing our options. The first thing that we took into consideration was monetary cost. For our use case, license fees to use a third-party software, cloud costs, as well as staffing costs to not only build, but to also maintain the gateway after it was created. That was our first consideration. The second thing that we took into account was added latency versus direct service-to-service calls, by adding another step that API calls must pass through. And this latency can grow, we wanted to know, as you add more custom plugins and business logic to your API gateway. And the third risk that we wanted to consider with API gateways is that they introduce a single point of failure as well as attack for hackers. So in essence, API gateways take independent microservices and couple them. Even if your system is well distributed, gateways pull a single config, which, if corrupted, can disrupt the entire compute plane. So these three things we wanted to make sure we took into account. So taking these key limitations from the previous slide, these were the questions in general that we tended to ask ourselves when we were weighing whether or not to stand up an API gateway. All boiled down to monetary cost, added latency, and introducing a single point of failure. And the aspect to call out here was that we made sure we asked ourselves first, was there an alternative solution that could have worked for us better than an API gateway? Was an API gateway really what we needed? So for example, depending on your use case, could you instead use direct service-to-service calls, OPA sidecar, service mesh, OpenTelemetry, etc.? So for those in the audience, pivoting here, who have already implemented one API gateway and are considering introducing more, let's talk through that thought process that we took at Vanguard when making that same decision. The main thing that we asked ourselves was, why doesn't my existing gateway fit the need? And is this use case for an additional gateway unique? So calling back to what Casey described earlier in the presentation. And on top of that, are there alternatives to a gateway that we could have used? We wanted to make sure of this first because an additional gateway, similar to introducing that first gateway, means additional costs depending on your licensing structure, additional staffing to support the additional gateways, and the third aspect, which was a major point at Vanguard, was coordinating between the multiple API gateway owning teams. We took a lot of care to make sure that all of our gateway owning teams at the company had channels that we could use to make sure that we were aligned with our implementation when problems arose or when major strategic changes needed to be made. So ultimately, we decided the benefits outweighed the risks. And today at Vanguard, we have multiple Kong API gateways that satisfy our unique use cases. So let's go through the key benefits that Kong API gateways have provided our users. So first, looking at the Kong API gateway that serves our external traffic, meaning traffic coming from outside of the Vanguard virtual private cloud, we've seen 4 main benefits. So let's talk through those 4 now. The first one, authentication, authorization, and audit. The Kong API gateway enables us to make sure that only valid users have access to our APIs and enforce the standard in a centralized way. Second, traffic management to protect our underlying services behind the gateway, in particular with server level throttling to prevent attacks, as well as enforcing per consumer level traffic quotas. We've also gotten the benefit of threat protection with the gateway, namely by integrating with our own WAF and custom security plugins. And last key benefit, analytics via logging integration and Kong Vitals. So for our Kong API gateway supporting internal traffic, the main benefit, similar to what Casey was describing earlier, that we've seen is it has allowed us to have an organized way to address our unique use cases instead of cluttering just one API gateway with multiple types of traffic. In particular, addressing an internal need that we identified for API standardization, stable URLs, as well as providing us universal plugins that we can apply to calls all across services linked to the gateway. An aspect that we wanted to note too is we are also at Vanguard looking into other technology that Kong offers, particularly Kong Mesh, to further support our internal traffic. All right, so to close off, we want to circle back to where we started the presentation, where Vanguard stands with our API modernization and where we see it going in the future. We continue to see APIs as a key ingredient to our technology strategy now and into the future. And if you go to the next slide, we can see this written. And as we continue to develop more and more APIs and move away from a monolithic tech strategy, managing these APIs at scale will become even more important. And as a result, so will the Kong API gateways that support these APIs. And we really continue to embrace Kong products in our journey. So thank you for listening to our presentation today, and we hope now that you have a better understanding of how many API gateways, one, none, or many, make sense for your use case. Thank you so much.